Notes for 11.6, arc length and sector of a circle. Pause this for a moment and use deductive reasoning to match these up. For all of these, you can think of them as being like part of a pizza. So arc length is c, and that is just going to be part of the circumference. So you think of that as like a crust on a thin crust pizza, that just the edge of it. The next one is sector, which is A, which goes from the center of the circle and is the part of the area of that circle. So you can think of it like being like that piece of pizza. The segment is D, which is the area between the circle and the chord. You can think of this as being like the stuffed crust pizza that's really, really puffy. That's the crusty, chewy, cheesy part that everyone loves. And the annulus is B, and this is the area between two concentric circles. Why you would not eat the whole pizza? Who knows? Now let's work through some examples together. Now let's do the area of a sector of a circle. So it's going to be x over 360 degrees for a circle, and we're only taking part of that circle, times the area formula for a circle, which is pi r squared. So the x is going to be the central angle times 360, so we're getting that fractional part. So in this case, it's 70 over 360 times pi times that radius squared, which is 5 squared. We go through this and start to solve it. So go ahead and do some mental math to reduce this fraction, where we get 7 over 36 times pi times 25. And when we multiply everything together, we get 175 over 36 times pi centimeters squared. Please remember to include the proper units. To find the area of the annulus, you're going to take the area of the large circle minus the area of the small circle. So we're going to use a little subscript here. We're going to use L for large and S for small. So it's pi r squared of the large circle minus pi r squared of the small circle. So the radius of the large circle is going to be 2 plus 3, which is 5. So it's pi times 5 squared minus pi times 3 squared. And we get our answer to be 16 pi. For arc length, we're going to use the circumference formula, but we only want part of the circle again. So we use x over 360 to get that part of the circle, times 2 times pi times the radius. So to figure this one out, the central angle is going to be 85 degrees. So we do 85 over 360 times 2 times pi times 12 inches. From here, we do some mental math, we do some reductions of fractions, and our final answer is going to be 17 pi over 3 inches, not inches squared, because we're talking about length, not area. So for the area of a segment, we find the area of the sector minus the area of the triangle. Now what we're going to notice from this formula is that one term has pi in it, the other one doesn't, so you're not going to be able to combine them. So for the area of the sector, it's going to be 90 over 360, that's the central angle, times pi times 8 squared, minus 1/2 times base times height, which are both going to be 8. This turns out to be a 45, 45, 90-degree triangle, so the base and height are going to be equal to each other. Doing some more mental math, reducing the fractions, our final answer turns out to be 16 pi minus 32 centimeters squared. Please make sure you leave it like this. Now pause the video and try these yourself. The one on the left has a central angle of 120 degrees. That's pretty straightforward. The one on the right is a square, and you have a 4 in it because you have 4 congruent circles with a radius of 3. Here's a harder problem that we will work through together. We're working backwards to find the central angle. So we know the area of the shaded region is 10 pi, and so we're going to take the area of the larger sector, which will be x over 360 times pi times 10 squared, minus the area of the smaller sector, which is going to be x over 360 times pi times 8 squared. Notice that each term has an x over 360 and a pi. So that's something we can factor out. So we get 10 pi is equal to x over 360 times pi. And then in the quantity, we'll take 10 squared minus 8 squared. Go ahead and divide out the pi. So we get 10 is equal to x over 360 times 36 go ahead and reduce the 36 and 360 to be 10. Multiply together and you get x to be 100. 100 degrees is your central angle.